Well, here we are, videotaping section 2.2, day 3. This is take 3 of this action shot video. The first time it ended up being only a minute long. The second time the sound was all off. So I'm hoping that today goes better. This is a fairly simple topic, so I don't know why the video is being so difficult. And behavior models, which you studied, I think, once in Algebra 2 and once last year. So hopefully this is not an unfamiliar topic to you, but it is a way that we find limits as x goes to infinity. We try to find an behavior model for each function, and we're primarily going to talk about polynomials. Just a little review about limits, finding asymptotes using limits. We have a horizontal asymptote over here on this side. When the limit goes to plus or minus infinity, if it equals some number, L, then y equals L is a horizontal asymptote. We're going to see that today. A vertical asymptote, remember, as x goes towards some number, if the limit is equal to plus or minus infinity, then you have a vertical asymptote at x equals that number it's going to. All right, so let's take a look at our lesson today. Consider the polynomial 5x to the 4th plus all those other terms. The end behavior model for that function would be just the first term, the one that has the largest exponent. And if we take the limit as x goes to infinity for this function, it also estimates the value of the f function and where it is going. So we look at both the limit to positive infinity and negative infinity. And we find that for an x to the 4th function, where we have an even exponent, that the limit is the same and it's equal to infinity. In this case, there are no horizontal asymptotes. If infinity came out to be a number, that infinity, then we would have some asymptote. Now, down here in these two little boxes down at the bottom, this is shown in your book, I believe. It says that the behavior models, when they are in the denominator with the function on top, the behavior model in the bottom, they should always equal 1, and that's how you can prove that it's a left-hand behavior model if it's going to negative infinity, or a right-hand behavior model if it's x is going to positive infinity. All right, we're going to look at 3 scenarios, one where the exponent's greater in the numerator, one where the exponent's greater in the denominator, and one where they're equal. So let's take a look at these two polynomials. Remember, end behavior models, we take the largest term with an exponent, and model that for both the top and the bottom as our end behavior models. So if we reduce 3x squared over x, which are the two largest in each, we just end up with 3x. So what we can do is we can estimate the limit of f of x as x goes to infinity, and I'm not going to write this all the time, is basically equal to the limit as x goes to infinity of 3x, because we have found its end behavior model. And this same statement is true as x goes to negative infinity, 3x. Now notice this time, they're not quite the same, but this limit as x goes to infinity goes to positive infinity. With x going to negative infinity, we have 3 times negative infinity. So, but again, we have, so these don't have to be the same, right? And behavior models left end, we're going in 2 different directions. But in this case, there are no horizontal asymptotes again. Okay, so let's take a look at the 2 exponents being equal. We take the end behavior models for each one again. Negative 2x cubed over 5x cubed. And when we reduce that, our x cubes cancel out, and we're left with negative 2/5. So again, we can take the limit as x goes to infinity and estimate the value of that limit with our function by using the end behavior model. limit x goes to infinity of -2/5. Therefore, our limit is -2/5. And voila, we have a horizontal asymptote at y equals 2/5. -2/5. And that will be our horizontal asymptote. Ha! Ha! I like to abbreviate things. Okay, going to the negative infinity, same thing. So that shows that we have the same horizontal asymptote. All right? Last but not least, when the exponent is greater in the denominator than it is in the numerator, our end behavior model, let's check and see what it is. Let's actually reduce this. Our end behavior model is going to be 2x to the 4th over 4x to the 5th. My board goes a little crazy sometimes. Look at that. Okay, so it equals 1 over 2 x's. Oh my goodness. Sometimes my board really goes nuts. You'll see. Well, I'll just put it right here, 1 over 2x. That is our end behavior model, 1 over 2x. Sometimes I write over here and just move it. There we go. All right, so when we go to infinity with this function, 1 over 2x, remember it's like 1 over a really big number, which approximately or heads toward 0. The same is true when x goes to negative infinity, 1 over 2x. We get a really big negative number, and therefore it is also going to 0. So now we also have a horizontal asymptote, y equals 0. Okay, so that is what those two limit statements tell us. And we already saw that right-end behavior models don't have to be the same as oh no, we didn't see that. That's in another example, and I don't think we really need to do that, but you don't always have the same end behavior models depending on which way you're going. And just keep that in mind. All right, that is our lesson, and voila, maybe it worked.